Hi students, I welcome you all for the sessions. Today we'll be going to continue on discussion on chapter 3, that is trigonometric functions. This lecturing hour is part number 6. This is video number part number 6 on the trigonometric functions. Okay, so in last class we were discussing about this trigonometric identities. So trigonometric identities what? So it is nothing but a trigonometric functions of sum and difference of a two angles, and the related expressions are called as trigonometric identities. Okay, so in last class we about 11 expressions we or 11 identities we have been derived. Okay, 11 identities are derived. Now we'll be continuing on that 12th one. So 12th one is that we have to prove cot of x plus y, cot of x plus y is equal to cot x, cot y, okay, cot x cot y minus 1 divided by cot y plus cot x. Okay, we have to prove, okay, we have to prove this one. Okay, how we can prove this one? So this the LHS term I am taking. Okay, we have to prove as LHS is equal to RHS, right? LHS is equal to RHS. Then from the LHS I am proving the RHS. This term I am proving. LHS term is what? Cot of x plus y. So cot of x plus y, how I can write? So cot is what? Cot is what? Cos divided by sine. Is it right? So cos divided by sine. So we know the formula of cos x plus y. Cos of x plus y is what? Cos x cos y minus sin x sin y. Right? So what about this formula for sin of x plus y? Sin of x plus y is sin x cos y. Okay, plus cos x sin y. Okay, here in plus term sin, one is sin, one cos will come, one cos is one sin will come, but in cos, so both term here cos will come, but here positive, when positive there in negative comes, and next two terms are sin, next two terms are sin. So here just you observe. So this equation, okay, in this equation, in this full equation, we just have to observe that here my one has to come. So one has to come means here, okay, this term we have to divide, by, okay, divide by on both sides sin x sin y. Okay, sin x sin y. If we divide this term sin x by sin y, then one will be get, right? One will be get. Therefore I am writing divide by sin x by sin y on both, numerator and denominator. Okay, numerator and denominator. So cot of x plus y is equal to, so cos x cos y, I am dividing by sin x and sin y, this term sin x sin y, and the second term also I am dividing sin x sin y. Okay, understood. And sin x sin y divided by sin x sin y. Okay, divided by again sin x cos y, dividing by this one sin x cos y, and plus cos x sin y and sin x sin y, sin x sin y. So all the four terms this, right? So numerator and denominator I am dividing these all terms by sin x and cos sin x sin y. Okay, so now if we simplify this one, okay, if we simplify these equations, cot of x plus y is equal to, now this sin x what will come here? Cos x divided by sin x is what? So it is cot x. So cos y divided by sin y is what? It is cot y, right? So the terms will not get cancelled. Okay, here cos x is there, then it will cancel. Here cos x sin x is there, it is cot x. Cos y and sin y is there, it is cot y. And these terms are same, right? Sin x sin y sin y sin. It is one. It will be get cancelled and will be get one. So now here in second one, the sin x is there, then it will be get cancelled. And what about this is sin y? Sorry, this is sin y. Okay, we are dividing sin y, right? Now this sin x will be get cancelled. Cos y sin y is what? cos and sin y is what? Cot y. And now in second term here we are having the cos x sin y and sin y will be get cancelled, and plus cos x divided by sin x is what? Cot x. Okay, so now it is proved, therefore is equal it is equal to RHS, right? So it is equal to RHS, we have been proved, right? So this term is LHS and this term is RHS. We are having the same equation here. Okay, cot x, cot y, cot x. Okay, this is proved. Hence, you write just as hence it is proved. Hence, it is proved. You write. Okay. Now we come to the derivation of cot of, okay, y x minus y. Okay, x minus y. Okay, this previous identity we have derived cot of x plus y, and we have to derive here cot of x minus y. Cot of x minus y we have to prove, as cot x cot y plus 1. Okay, plus 1 divided by cot y minus cot x. Okay, this one we need to prove. Okay, we need to prove. So to prove this one, so we are taking LHS. So cot x minus y. Okay, x minus y x minus y. So before to so derive this equation. Okay, suppose if in your examinations will be asked, okay, in your examinations will be asked this one, then you have to write we have to write cot of x plus y expressions as previous expression we have been written. What is the previous expression? So previous expression is that, so cot x, okay, the previous expressions, sorry, this previous expression I am writing here. Previous expression is what? So cot x cot y minus 1. So we know that, you just write, we know that cot of x plus y is equal to cot y plus cot x. Okay, cot x. So in this equations, okay, in this equation replace, okay, replace y by minus y, we have to replace y by minus y, then it is x minus y, right? So we are replacing y by minus y by, it is cot x minus y. Now this term cot x is cot x, cot y is minus cot of minus y and minus 1, and this is cot of minus y and plus cot x. Okay, so this is we are writing LHS term. Okay, we are writing LHS term, and now this is LHS, and now we have to prove the RHS term. So these cot x is cot x. The cot of minus y is what? So we know the right, tan of minus x is what? Minus tan x. Okay, we know that. Okay, we know that. So all these reasons we have to write inside here. You just write here side. Okay, we know that. You write. I mean, you just write cot of minus x is minus cot x. Okay, minus cot x, because tan of minus x is minus tan x, cot is reciprocal of, therefore it is minus cot x. So minus cot x means here cot of minus y is minus cot y, then minus is comes here, then it is cot y minus 1, and cot of minus y is minus cot y and plus cot x. Now we can take the minus term or outside. So if it take the minus common, so minus common, then it is cot x cot y, this is plus 1. Okay, this is plus 1, and take this minus also here, then it becomes cot y minus cot x. Understood? So minus minus will be get cancelled, and finally we will be having cot x cot y plus 1 divided by cot y cot x. Understood? Hence it is proved. Hence it is proved. This is equal to RHS. Hence it is proved. Is it right? We have been proved. So this equation, okay, this equation is same as this equation, right? Then it is proved. Then it is proved. 13 is proved. Equation 13 is proved. Now we come to the, now we come to the 14th one expressions, that is cos 2x. So cos 2x, here we have to prove many more things. Okay, here we have to prove cos 2x is nothing but a cos square x minus sin square x. Okay, and also we need to prove cos 2x is equal to cos 2 is 2x is equal to 2 cos square x minus 1. And also we need to prove cos 2x is a 1 minus 2 sin square x. Okay, and also we need to prove cos 2x is 1 minus tan square x, 1 minus tan square x divided by 1 plus tan square x. All these we need to prove. Okay, all these we need to prove. So first one we going to prove, that is a cos 2x. So cos 2x we need to prove. And here, to prove this one cos 2x, so to cos 2x for the first one. Okay, this is, you say, first one, second one among the 14. Okay, this is third one, fourth one, first one I am proving. So cos 2x is equal to, we know that, you just write, we know that cos of x plus y, right? So we know that cos of x plus y is what? So it is cos x cos y minus sin x sin y. Okay, this one we know, right? This formula we know. What I do here, so here I am replacing, so replacing y by, okay, y by x. So if we replace y by x, then it becomes cos 2x, right? It becomes cos 2x. So then x plus x, y is replacing by x, and then it is the cos x cos x, and then sin x. So y is, okay, replacing y by x, then it is sin y. Now what is this term? Oh, this is sin x. Okay, now this is a cos 2x. This becomes a cos 2x. Cos into cos, the x axis is there. Okay, x, here x is there, here x is there. Then we can cos square x we can write. Here x is there, then we can write the sin square x. Okay, is it right? Then it is proved. Okay, the first one is proved. Hence it is proved. Hence it is proved. Okay, here you write, just write as LHS is equal to RHS. You just write LHS is equal to RHS. Then you next write, hence it is proved statement. Now we have to prove the second one. So the second one is that, so among in the 14th, the second one is that we need to prove cos 2x is equal to 2 cos square x minus 1. We have to prove. Okay, cos square x minus cos square x minus 1 we have to prove. Okay, in this, to prove this one, we know that, okay, we know that cos 2x is what? So this one, okay, this one, this one we have proved. Cos 2x is what? So cos 2x we can write as a cos square x minus sin square x. Is it right? So is it right? Okay, then how? So this cos 2x is equal to, I'm writing, so here we need to prove this sign is their term, this sign term we have to express in terms of cos. Okay, then we know that, you just write here, what sin square x plus cos square x is what? The formula is 1. Okay, the formula is 1. So here sin square x, how can write this? Sin square x is, I can write, it is 1 minus cos square x. Is it right? 1 minus cos square x. So the same thing I'm writing here, cos square x minus sin square x is 1 minus cos square x. 1 minus cos square x. Right? Is it right? So this is right. Now we are writing here, so this is equal to cos 2x is equal to cos 2x is equal to cos 2x is equal to, so then it becomes what? This is the cos square x minus 1, then it is plus of cos square x, right? Minus minus 1 and plus, minus into minus plus. So therefore it is cos square x is here, cos square x is, it is 2 cos square x minus 1. Okay, then here LHS is equal to RHS. Then you can write, hence it is proved. Hence it is proved. Hence it is proved. Okay, now come to the third one. Third one, we need to prove cos 2x is 2 sine, not 2 sine, 1 minus. So we have to prove 1 minus 2 sine square x. So same procedure we have to repeat it, that we know that, just write, we know that cos 2x is what? Cos 2x is cos square x minus sine square x. So here we need to express 2 sine square x. It means what? This cos x square we need to express in terms of a sine square x. Therefore, here we know that, so sine square x plus cos square x is what? Is equal to 1. Okay, you just write here side. So we know that, then we have to express this cos square x. How cos square x, how it can be, right? This term cos square x we can write as a 1 minus of sine square x, right? Isn't it? So now I'm writing here cos square x is 1 minus sine square x and sine square x. Okay, now this is here minus sine square x minus sine square x, then it is 1 minus 2 sine square x. Is it right? So then it is LHS is equal to RHS, and hence it is proved. Hence it is proved. Okay, hence it is proved. Now we come to the discussion for the fourth one. So fourth one is that we need to prove cos 2x is 1 minus tan square x divided by 1 plus tan square x. Okay, we need to prove this one. So to prove this one again I am calling the same here. So again the same the formula I'm calling here, cos 2x is equal to cos square x minus sine square x, right? Is it right? So what I do here, so cos 2x is a cos square x minus sine square x. Here denominator term will be 1, right? So denominator, if nothing is but here 1 will be there. Okay. Okay, here suppose if any 2 is there, means here 2 by 1. So 3 is there, it is 3 by 1. So in here denominator will be 1. It is not a 0, right? Denominator term is not a 0. So here always the term will be 1. So suppose you take any numbers. So 2, 3, 5. Here 1 will be there. Okay, 1 will be there. So there this one. So this one how we can write? So this is cos 2x. Okay, so this is cos 2x. Now this, so cos square x minus sine square x, the one is what? One is what? Sine square x plus cos square x is equal to, okay, cos square x is equal to 1. Okay, so then this we can write here sine square x plus cos square x is equal to 1. 1 we can write in 1 we can write sine square x plus cos square x, right? Isn't it? Okay, now will be you just observe this term. So here, okay, now you just observe this term. Here 1 has to come. 1 has to come means we have to divide cos square x. Okay, both terms. So dividing by, so divide divide cos square x on both numerator and denominator. Okay, denominator. So therefore here we can write cos 2x. So cos square x will be, okay, each term will be divided by cos square x sine square x divided by cos square x, and now this is sine square x divided by cos square x, and plus cos square x divided by cos square x. Okay, you simplify this equation, cos square x will be get cancelled. 1 minus sine divided by cos, right? This is sine by cos means what? It is tan square x, and now this is sine by cos is what? Okay, sine by cos is what? So this is what? Okay, this is tan square x, and what about this cos square will be get cancelled, 1 plus. Okay, so this is equation, and also this can, or we can write a 1 minus tan square x. Okay, this one we write, we can, this second term we can write 1 plus tan square x, the meaning is same. Then now it is LHS is equal to RHS, we have been proved, hence it is proved. hence it is proved. Okay, hence it is proved. Understood? So totally we are having four formulas. Okay, what we have been derived, cos 2x is equal to cos square x minus sin square x, we have been proved. And also cos 2x is equal to 2 cos square x minus 1, and also it is equal to 1 minus 2 sin square x. So and also it is 1 minus tan square x divided by 1 plus tan square. All the four derivations you have derived in the in the in the cos 2x. So these formula we have to use where the necessary is there. Okay, so where the necessary is there, according to that problem statement we have to use this formula. Okay, so now we go to the 15th one. So that is the now we are going to the 15th one expression, that is sine 2x. So sine 2x we need to prove 2 sin x cos x, and also we need to prove sin 2x is equal to 2 tan x, 2 tan x, so 1 plus tan square x, 1 plus tan square x. We need to prove sin 2x is equal to 2 sin x cos x. And to prove this one, first one, okay, here we are having two expression in 15. Okay, first one is what, 2 sin 2x is what, 2 sin x cos x. To prove this one, what we have to do, so we know the formula as previous case. Okay, so as how previous we have been implied, so in like that we have to so right, cos 2x, how cos 2x is first we have been written here. Okay, I will just show cos 2x is written here. Okay, cos 2x here, cos 2x is written from the cos of x plus y. Therefore here also we can write sin 2x as a sin of x plus y. Okay, sin of x plus y is sin x cos y plus cos x sin y, we can write, isn't it? Now this replacing, now we are replacing y by x, then it is becomes sin of x plus x. Okay, then you sin x cos x, and then cos x sin x, right? So replacing y by x. Now this becomes sine 2x, right? X plus is x, what it is, x plus x is what, sine 2x. And sin x cos x, here also sin x cos x, two terms are there, then we can, two terms are same, therefore we can write 2 sin x cos x, 2 sin x cos x. Therefore this is LHS is equal to RHS, hence it is proved. Okay, hence it is proved. Okay, hence it is proved. Okay, come to the second one. We need to derive sine 2x is equal to 2 tan x divided by 1 plus tan square x. Okay, already we derived here sine 2x is equal to, so we know that, you just write here, we know that sine 2x is equal to 2 sin x cos x. Is it right? Okay. Here, so here denominator term will be 1. Okay, this one we can write in the form of, okay, 2 sin x cos x. So we know one is what, so cos square x plus sin square x, right? So now you compare this term. Okay, you compare this term with this RHS term. So here we are having 1, so 1 has to come, means what, we have to divide. So 1 we have to divide cos square x, then it will come 1 divide by cos square x. So on both sides, denominator and numerator, okay, we have to divide this cos square x on numerator and denominator, both sides. Now if we divide this, okay, so we'll get sin 2x is equal to 2 sin x cos x divided by cos square x. Okay, and again cos square x, denominator term is the cos square x divided by cos square x plus sin square x divided by cos square x. Okay, now you simplify these equations, cos x will be get cancelled, and one cos x will be remained. Okay, it is square, it is square means here one cos x is remained. Therefore sin by cos x is what, sin by cos x is 2 tan x. Okay, here 2 is there, it is a tan x. Okay, sin by cos x is tan x, and here 2 is there, therefore it is 2 tan x. So this is cos square. One cos will be get cancelled, and now cos and cos will be get cancelled. It is 1 plus sin square x and cos square x is the ratio of, okay, tan square x. Okay, hence it is proved. This is RHS term, right? So 2 tan x divided by 1 plus tan square x. Hence it is proved. Hence it is proved. You just write here. Hence it is proved. Hence it is proved. Now come to the, so 16th one, the 16th expressions. 16th expression is that tan 2x. So tan 2x is equal to 2 tan x divided by 1 minus tan square x. Okay, here in previous example it is 1 plus, right? So 1 plus tan square x. Okay, so here previous expression sin 2x is 2 tan x 1 plus tan x tan square x. Here we need to prove, so tan 2x is the 2 tan x divided by 1 minus tan square x. Okay, you just understand here the difference. Okay, so here 1 plus is there and 1 minus is 1 minus. So this one we need to prove. How? So we prove that this ones, okay, we know that, okay, we know that, so tan of x plus y expressions as previously we have been derived, we know that what is tan of x plus y. Tan of x plus y expression is the tan x plus tan y 1 minus tan x tan y. Okay, this one we know as previously we have been derived, right? So in this expression, so what I do here, replacing, so replacing, so tan 2x has to come, means what, the y is replaced by, okay, y is replaced, replace y by x. Okay, replace y by x. So if we replace here y by x, then it is x plus x, and now this is tan x, and y is, if we replace y is x, then it is tan x. Now it is tan x, and y is tan x. Okay, you write this tan x, what tan x, then it will be add, right? X is there, then it is 2 tan x. Okay, 2 tan x, and here 1 minus, this is tan x, both terms are same, then it is square. Okay, 1 minus tan x square. So okay, this is our system, right? So hence we proved, hence we proved, you just write hence it is proved, hence it is proved. Okay, now come to the 17th one expressions. Okay, 17th one expressions. All these expressions you need to remember because these will be helpful for solving the numericals. Okay, these are the derivations. You just, these are the derivations, and these derivations will be called as trigonometric identities. Trigonometric identities. So next we need to prove sine 3x is 3 sine x. Okay, it's 3 sin x minus 4 sin cube x. This one we need to prove. How we will be proving? So this sin 3x will be written. So here we are writing this LHS. Sin 3x we are writing in the form of sin 2x plus x. You can write. So sin 3x will be written as a 2x plus 3x. 2x plus x. You can write. Right, the meaning is same here. So this 2x plus x is what? It is in the form of okay, we know that. So we know that what is the formula for sine of x plus y. So sine of x plus y is 2 sine, not 2 sine, sine of x plus y is what? So sine of x plus y is, what is the formula for the sine of x sine of x plus y? Sine of x plus y formula is sine x, okay, sine x cos y plus cos x sin y. This formula, right? This one we know, right? So in the same manner we have to put this value. So here sine, so first term 2x and cos x is this second term plus cos first term, okay, then sine second term. Okay, we, I have been written this as per this formula, right? Now, so now we considering this, okay, sine 2x. So here sine 2x, we know the formula of sine 2x is 2 sin x and cos x. Okay, this one we know, right? We can put the formula of sin 2x is the 2 sin x cos x, and here cos 2x formula, so we need to put here cos 2x. So here cos 2x formula we need to fill in the terms of sine square. Okay, cos square, sorry, here, so here, so I will put, so cos 2x formula will be written in the form of a sin x, because we were having sin x term here. So therefore I am writing cos 2x in the terms of sin x. Then it is 1 minus 2 sin square x. This formula you know, right? We have been derived. So therefore, why I am writing in the form for 1 minus 2 sin square x? Because here sin x term is there. Therefore, I am cos 2x is writing in the form of 1 minus 2 sin square x into sin x. Okay, understood. So now if we simplify this, this is the sin x cos square x. Okay, sin x cos square x, uh, sin x cos square x. Okay, this is cos square x. Then what about this? So this sin x, if we multiply this one, sin x minus 2 sin cube x, isn't, is it right? So here sin into 1 is sin x, sin into minus 2 is minus sin cube x square, and 1 is cube x, right? So now this 2 sin x is cos square x, how we can write? So cos square x we can write 1 minus of sin square x, because the cos square x plus sin square x is what? 1. Then we have to write here sine term is there, so then we have to write in terms of a sine, so cos square x will be written 1 minus of a sine square x. Okay, here 1 minus sine square x. Why we are writing this cos square x 1 minus square x? The sine x is term there, therefore we are writing 1 minus sine square x, and here this term is sine x minus 2 sine cube x. Understood? So now you simplify these equations, so just multiply this with this here, then it is 2 sine x, and this is 2 sine cube x plus sine x minus 2 sine cube x. Now you simplify these equations. We are having 2 sine x and 1 sine x. It becomes a 3 sine x. It becomes a 3 sine x, and minus 2 sine cube and minus 2 sine cube is there. Then it is becomes a 4 sine cube x. Okay, then it is proved. Then it is RHS. Hence it is proved. Okay, 17th one is sine 3x is 3 sine x minus 4 sine cube x. Now 18th one we have to, so we have to uh, show the expressions. We have to derive the expression of cos 3x. Cos 3x is 4 cos cube x minus of 3 cos x. Okay, so these two terms are relatively same. So, but here second term 4 sine cube will come, here 4 cos cube will come. Okay, you just understand the meaning. Okay, now this cos 3x I'm writing in the same fashion in the 17 what we have written, sine of 2x plus x. In the same way I'm writing here cos of 2x plus x. Okay, we know the formula of cos of x plus y, that is cos of x plus y is what? Cos, okay, cos minus sine x and sine y. Then here I am writing cos 2x, then it is 2x sine x. Understood? Cos 2x, because we know the formula of here cos of x plus y is what? Cos of x plus y is cos x cos y minus sine x sine y. Okay, so here x is 2x and y is x in this expression. Okay, now how we can simplify this equation? So this cos 2x we can write in terms of a cos. How we can write? Cos 2x will be written as a 2 cos square x minus 1. Okay, this cos 2x we have to write in terms of a cos, because the cos term is there. Okay, cos term is here, therefore we are writing cos 2x is a 2 cos square x minus 1, then it is cos x. Okay, here sin 2x we know the sin 2x we know, sin 2x is what? 2 sin x cos x, 2 sin x cos x into sin x. Okay, sin 2x is what? 2 sin x cos x. Now I will be multiplying this equation. Okay, so this will be 2 cos cube x Okay, if I multiply this, then it becomes 2 cos cube x. Here minus cos x. Okay, then it is 2 sin square x. Sin is here, 2 sin square x cos x will come. Okay, now so what I will do, this 2 cos cube x minus cos x and minus 2 sin square x, how we can write? So sin square x is 1 minus cos square x, right? 1 minus cos square x. So because sin square and sin square x plus cos square x is what? 1. So therefore if we simplify this again, then it becomes 2 cos cube x minus cos x and minus 2, here cos x is there, okay, minus 2 cos x and minus into minus plus, so 2 cos cube x. Understood? This 2 also we have to multiply and cos also we have to multiply. Okay, then now if we 2 cos cube and 2 cos cubes, okay, then it becomes 4 cos cube x and here minus 1 cos and minus 3, it becomes a minus 3 cos x. Hence it is equal to RHS, right? This is equal to RHS. Hence it is proved. Hence it is proved. Okay, so cos 3x is what? 4 cos cube x minus 3 cos x. Now come to the 19th one. So 19th one we need to prove tan 3x. Okay, tan 3x is 3 tan x minus tan cube x. Tan cube x divided by 1 minus 3 tan square x. Okay, we need to show this one. So as here also we are writing tan 3x is tan 2x plus x. Okay, this formula we know, tan of x plus y is 2 tan. Okay, what is the formula of tan of x plus y? Tan of x plus y is, okay, all the reasons you have to write here side. Okay, all the reasons you have to write in the side. Tan of x plus y is tan x plus tan y, we know, and this is 1 minus tan x tan y. We have to write in this form, this equation. So therefore here, so tan x, okay, so this one we have to write here. So tan x is what? 2x. Okay, then it is tan 2x, tan y is x. Okay, tan x. Now this one minus tan 2x tan x. Is it right? So tan 2x formula we know. Okay, tan 2x formula we have been derived, right? Okay, you just write here. So you just write here. We know that tan 2x is what? 2 tan x. Okay, 2 tan x. 2 tan x 1 minus tan square x. Okay, the here, so tan 2x will be written here. Tan 2x is 2 tan x, 2 tan x 1 minus tan square x and plus tan x is here. Okay, so now 1 minus here tan 2x, another tan 2x is that, then we can write 2 tan x divided 1 minus tan square x. Now here tan x multiplication is there. Okay, tan x multiplication is there. Now if you simplify this equation, okay, if you simplify these equations, 2 tan x, okay, this is tan 3x, LHS is tan 3x, so 2 tan x, this I am taking the this LCM I am taking this is tan x 1 minus tan square x. Okay, okay, here this one multiplying here, then it is LCM. Now the LCM is 1 minus tan square x. Now the second, this equation 1 minus tan square x, I'm taking multiplying in this side. Okay, because I'm taking the LCM 1 minus tan square x, and here minus of 2 tan x and tan x is there. It becomes a 2 tan square x, and denominator term is what? 1 minus tan square x. Okay, 1 minus tan square x. So this term will be get cancelled, and remaining term what we are having, 2 tan x plus 2 tan x plus, okay, here I will be multiplying this tan x, then it becomes a tan x tan cube x. Okay, now this denominator term is this minus tan x square minus tan x square, it is 1 minus 3 tan square x. Okay, 1 minus 3 tan square x, 1 minus 3 tan square x. Okay, now if further we simplify this one, further if we simplify this one, 2 tan x plus 1 tan x, it is becomes a 3 tan x, right? It becomes a 3 tan x, and tan cube x divided by 1 minus 3 tan square x. Okay, so this is equal to RHS, right? This is the same as RHS term. Okay, 3 tan x, so 3 tan x, this and this are equal. Okay, this term are equal, hence it is proved. Okay, you just remember tan 3x is what? 3 tan x minus tan cube x 1 minus 3 tan x square. This formula you need to remember. Now we come to the 20th formula. Okay, now we come to the 20th expressions is that, so in 20th expression we need to prove four things. Okay, cos x plus sin cos y, so that is equal to 2 cos of x plus y by 2 and cos of x minus y by 2. We need to prove first one, and second one is cos of x minus cos of y is equal to 2, so sin x plus y divided by 2 and sin x minus y by 2. You just remember both terms will be cos, then plus is there, then it is 2 cos will come. Okay, here x plus y by 2 and this is x minus y by 2. When minus comes here, it is minus 2 sin will come. Okay, like that we have to remember. Okay, third one is that, so third one is we sin x plus sin y. Okay, sin x plus sin y, this is, so when sin will come, plus sign will come, it is one term is sin and another term is cos. Okay, another term is cos. Okay, suppose if fourth one sin x minus y will come, then here, so when minus term, sin minus term will come, then first term is cos and second term is sin. Second term is sine. Okay, you just remember this formula. First cos plus will come, then it is both term will be plus, both term will be cos, and when it is minus, both term will be sine and it is minus. When the both sine and plus will be there, then it is more, first term is sine, second term is cos. When minus, then it is cos and this is sine. Okay, so we need to prove these equations. Okay, we need to prove these equations. To prove these equations, we have to recall the formulas. We have to recall the formulas. What is the formulas? Cos of x plus y and cos of x minus y. What is the formula for cos of x plus y? So when plus is there, then minus come here. Okay, cos x cos y, plus means here minus sin x sin y. Okay, then it is minus, then it is plus will come. First two terms are cos only, cos x cos y and sin x sin y. Okay, these formulas we know, right? We know these formula. Now what we have to do, now what we have to do, adding and subtracting these two equations. Okay, we need to, this is, we call this equation number 1 and equation number 2. Now what we have to do, adding, so we have to add the equation 1 and 2 and subtract the equation, and adding and subtracting the equations 1 and 2. So first we add the terms, these two terms I am adding, and next I am doing the subtractions. So then it is x cos of x plus y and plus cos of x minus y. Okay, you just add these two terms. Okay, this, when we are adding these two terms, this will be get cancelled, then it is 2 cos x, 2 cos x cos y will be remained. Is it right? So this is equation number third. When we are adding these two terms, these two terms will be get cancelled, then it is 2 cos x cos y. When we are subtracting these two equations, okay, suppose if we are subtracting these two equations, x plus y minus of cos of x minus y. Okay, if we subtracting these two equations, what comes? Okay, so here comes, it comes minus 2 sin x sin y, minus 2 sin x sin y. This is the 4. So when we are minusing, then this term is minus, this term is minus, this will be get cancelled, and this minus minus is 2 sin, minus 2 sin x sin y will come. Understood? You just try, we'll be get these terms. Okay, now further what we have to do, so here, the equations, further we know the equation for, So we have written cos x and cos y. Further, we have to write the equation of sine of x plus y and sine of x minus y. Okay, these formula we know, right? So here two formula I have written. So one is that one is cos of x plus y and the cos of x minus y, and these two equation I am adding, and by adding I am getting this term. By subtracting these two equations I am getting this term. Now we have to recall the another two formula of sine of x plus y and sine of x minus y. Sine of x plus y is what? Sine of x plus y is sine x cos y plus plus uh, plus so plus cos x sin y, and sine of x minus y is what? So sine of x minus y is sin x cos y. Here minus will come. Okay, so minus cos x sin y. Okay, so these two formula we know. This equation is 5, this equation is 6 I am giving, and same thing we have to do here as we before, adding and subtracting these two equations, adding and subtracting the equation 5 and 6. First I will add these equations. Sine of x plus y plus sine of x minus y. Okay, when adding these two equations, this term, the second term will be get cancelled, and we are having sine x to sine x to sin x cos y we are having. So if we subtracting these equations 5 and 6, if we subtracting equation 5 and 6, these two is subtracting, then we are having, so then we are having, when subtracting means it is minus, it is plus, then these two will be get cancelled, and this is 2 cos x sin y will come. Okay, 2 cos x sin y. This equation is 7, this equation is 8. Okay, now so now what we have to do here, so in this x plus y, in x minus y, I am replacing the terms. So that is so x plus y is equal to theta. I am taking x plus y is equal to theta, and x minus y is equal to, this is pi. Okay, this is pi. I am replacing these terms. Okay, I am replacing these terms in the equation, which equations? In equations 3 4 7 8. Okay, in the equation 3 4 7 8, 3 4 7 8, I am writing the things here. So if in the three equations cos of x plus y, then here in these equations, in this equation put x plus y is a theta, then it becomes a, okay, so put these terms in equation 3 4 7 8, 3 4 7 8, and then it becomes cos theta plus cos pi is equal to, so is equal to, okay, this cos x plus 2 cos, and okay here, okay here again I am simplifying this one. So x plus y is equal to theta, x minus y is equal to pi. What about x here? So what about x here? So x is what? So here one assume you have to do is that, one assume you have to do that x plus y we have to put as a theta, okay, and x minus y we have to put as a pi, and therefore if we write x is equal to, so x is equal to, we can write theta plus pi by 2. Okay, y we can write as theta minus pi by 2. Okay, so these terms we need to put the in the equation 3 4 3 4 7 8. In the equation these terms we need to put. Okay, x plus y we have to replace x plus y by theta, and x minus y pi, and x is we have to replace theta plus pi divided by 2, y is theta minus pi by 2. Okay, the third equation is that So third equations I'm showing here, cos of x plus y. Cos of x plus y means, so cos of x plus y, we are having x plus y is what here, theta. Then it is cos theta. Then it is cos theta. Next is cos of x, here cos of x, okay, cos of x minus y is there. Okay, cos of x minus y is there. Okay, cos of x minus means it is cos pi. Cos pi. Then here, so third, 3, 4, these are the new equations we got, right? 3, 4, 3, 4, 7, 8. I'm just showing here. So 3, 3, 4, 7, 8. These are the new equations we got after adding and subtractions. Okay, the same, that one I'm writing here, same thing. So here 2 cos x, x is what? So x is 2 cos x, x is what? Theta plus pi divided by 2. And next is cos y, y is theta minus pi divided by 2. Now, and fourth equations we are having cos theta minus cos pi. Okay, and here, so minus 2 sine theta plus pi divided by 2, sine theta minus pi by 2. You just check these equations. Fourth equation is what? So fourth equation we are having minus sign, not minus, sin x plus y. Sin x is sorry, minus 2 sin x sin y we are having, minus 2 sin x sin y we are having. Okay, what about the seventh and the eighth equations? Seventh and eighth equations are sin, so here seventh equations we are having x sin, okay, sin theta plus sin pi. And seventh equation we are having sin theta minus sin pi, and this will become here 2 sin x cos y. Okay, 2 sin x, 2 sin x means what? X is what? Theta plus pi divided by 2. Cos is what? Theta minus pi by 2. And here eighth equation is that, eighth equation is 2 cos sin. Okay, first term is cos, then it is theta plus pi divided by 2. Second term is sin, it is theta minus pi by 2. Okay, so these values, these x plus y is equal to theta and x minus y is equal to pi, and x is theta plus pi by 2 and y is theta minus pi 2. These values we need to put in the equation 3, 4, 7, 8. Then we got this equation. Okay, the respective of equation of these equations. Okay, respective equations will be get. Okay, now what we have to do, so we have to replace, we have to replace okay, now we have to replace theta by x and pi by y. We have to replace these equations, these new equations. We have to replace these new equations by theta by x. Okay, I'm writing here. Then it is cos x plus cos y. Okay, cos x plus cos y. Then it is 2 cos x plus y, x plus y by 2. This is cos x minus y by 2. Okay, the second equation is cos x minus cos y. Then it is minus 2 sine x plus y by 2. This is sine x minus y by 2. And the third one is what? We are having the sine x plus sine y. Sine x plus sine y. Then it is 2. First term is sine. Second term is cos. Okay, second term is cos. And when it is negative, sine x minus sine y. First term is cos. 2 cos, 2 cos x plus y by 2. Second term is sin x, x minus y 2. These are proved, right? Hence it is proved. You just check the equations here. So these four terms are we are having last and the final. Okay, these are the final. Then this is LHS is equal to RHS. Then we can write LHS is equal to these four terms, right? These four terms are same as the before. Therefore, LHS is equal to RHS. You just write. Okay, RHS. So these are the formulas, and here we got the formula for, okay, we got the formula for here. So in the equation 3, 4, Okay, in equation 3 4, okay, this equation 3 4 7 8, in the equations we got 3 4 7, the equation 3 4 7 8 I am writing here again. These are also formulas. Okay, the equation 3 is what? So in equation 3 we got 2 cos x cos y is equal to, when we are adding cos of x plus y and cos of x minus y, when we are adding, okay, when we are adding the formula for cos of x plus y and cos of x minus y, we got this term. Okay, we got this term. So okay, we got this term. So this can be written as cos x cos y. So cos x cos y, we can write 1 by 2 of cos of x plus y, cos of x plus y plus cos of x minus y. Okay, this is also one formula. This is also formula. And if we write so sin x and sin y, sin x and sin y from the fourth equation, this is from the third equation, this is from the fourth equation. Sin x sin y, it is minus 1 by 2 of cos of x plus y, cos of minus cos of x minus y. When we are subtracting these two, subtracting these two, then we are having sin x sin y we got. Okay, this is the another formula. And from the fifth term we got two from the fifth, so we'll be having sin x cos y, 1 by 2 of 1 by 2 of sin of x plus y plus sin of x minus y. This is another formula. And from the seventh one we got the term that is cos x sin y. Okay, cos x sin y, that is 1 by 2 of cos of x plus uh, sorry, not a cos of, here we are having the cos x sin y is this is subtractions, x plus y minus of the sin of x minus y. Okay, these are the new formulas. Okay, these are the new formula we get from the equation number 3 4 5 7 3 4 7 8. Okay, so this 3 4 7 8, this two taking, I'm this side. Okay, these two taking this side, so then we'll be having these formulas. Okay, then we are having these formulas. Okay, you just okay, you write these formula, new formula. Okay, when we are adding cos of x plus y cos of x y, these we got 2 cos x cos y, this two term I'm taking this side. Okay, when we are subtracting cos these terms, we will be having minus 2 of sin x sin y, then minus 2 I'm taking this side. So when we are adding sin and sin term, then we will be having 2 sin x cos y we got, then two term I am taking this side. And when subtracting these two terms, I am this 2 will come here, this 2 I am taking this side. Okay, you just these equations we got from the 3 4 7 8. Okay, these are the new formula. Okay, now we have all the expressions we have been completed. Now we will be next class we'll be going to discuss on solving the examples based on these expressions, and also we'll be solving the exercise 3.2. Okay, thank you for watching the video. Please subscribe the channel and hit the bell icons for the notifications. Please do share with your friends and make the like video. Thank you.